Have you ever wondered what it would be like if you could alter life's building blocks? Picture this, a world where we could tap into our DNA to eradicate diseases or even enhance our abilities. This isn't a fantasy. It's the promising reality of genetic engineering. It's the science of modifying the genetic material of living organisms. Can you imagine the possibilities? The power to change life at its core. Well, that's what genetic engineering is all about, and today we're going to dive deep into this fascinating world. Imagine having a toolbox where each tool represents a gene. This isn't your typical toolbox, though. It's a genetic toolbox. Just as a carpenter uses different tools for different tasks, a genetic engineer uses different genes to create different traits in an organism. Now let's delve a little deeper into what genetic engineering actually is. In a nutshell, it's the manipulation of an organism's genes. This manipulation can take several forms: adding genes, removing genes, or modifying existing genes. Picture this. You're working on a wooden sculpture. You realize you need to add a curve to your sculpture, so you reach for a chisel in your toolbox. In the world of genetic engineering, the chisel is akin to a gene that you would add to an organism to create a new trait. Conversely, if you needed to remove a piece of wood, you might use a saw. In genetic terms, this would be equivalent to removing a gene to eliminate a trait. But what if you already have a curve and you just want to modify it? You'd probably use sandpaper to smooth it out or make it more pronounced. Similarly, genetic engineers can modify existing genes to alter an organism's traits. So, where does DNA come into play? Well, DNA is like the blueprint for your sculpture. It contains the instructions that tell your tools, or in this case your genes, what to do. And just as a skilled carpenter can create a masterpiece by skillfully manipulating his tools, a genetic engineer can create a genetically modified organism by cleverly manipulating its genes. But remember, while a carpenter's toolbox can create beautiful works of art, a genetic toolbox has the potential to do much more. It can create crops that are resistant to pests, animals that produce more milk, or even humans that are immune to certain diseases. In essence, genetic engineering is like us playing with our toolbox, only this toolbox has the power to change life itself. Now, what can we do with this powerful toolbox? Well, genetic engineering is like a Swiss Army knife for biology. It has a multitude of applications that continue to evolve and expand. Let's start with genetically modified organisms, or GMOs. These are living things whose DNA has been altered. For example, scientists have engineered bacteria to clean up oil spills, and glow-in-the-dark cats to help us understand genetic diseases. Next, we have the potential to fight diseases. Imagine a world where genetic disorders can be corrected at the source, eliminating conditions like cystic fibrosis or muscular dystrophy. This is no longer science fiction, as researchers are already making strides in this direction. But the potential of genetic engineering doesn't stop there. It extends to our food as well. By tweaking the genes of crops, scientists can make them more resistant to pests, diseases, and harsh weather conditions. This could lead to more abundant and sustainable food production, helping to address the challenge of feeding a growing global population. It's not just about quantity, but quality too. Genetic engineering can enhance the nutritional content of food, packing more vitamins and minerals into every bite. Imagine a world where a simple bowl of rice could provide all the nutrients a body needs. So, from fighting diseases to feeding the world, the possibilities with genetic engineering are almost limitless. Let's take a quick trip back through what we've learned. We started off with the big question: what is genetic engineering? We discovered it's about manipulating the very blueprint of life, our DNA, to create changes in living organisms. It's like being a master architect, but for life itself. We then delved into the intricacies of genetic engineering. We learned about the role of DNA, the double helix structure that holds the genetic instructions for the development, functioning, growth, and reproduction of all known organisms. It's the code that makes you, and me, me. Finally, we explored the power and potential of genetic engineering, from curing genetic diseases to improving crop yields, and even potentially bringing back extinct species. The possibilities are vast and exciting. So, the next time you wonder about changing life's building blocks, remember, with genetic engineering, it's not just a flight of fancy, but a reality we're living in.
Thanks for watching and don't forget to subscribe.